Okay, so question C, continuing on. It's asking us to look at the cell represented below, which is the iron 2 plus, iron 3 plus couple with a thallium 3, thallium 1 couple. We've been given the overall equation voltage, which is plus 0.48 volts, but this time it's asking us to calculate one of the halves. Now we know that the overall cell potential, which in this case, as I say, is 0.48 volts, is equal to the cell potential of the right hand side minus that of the left hand side. So we know that that is equal to whatever the right hand side happens to be, because that is now ultimately the x value in our equation, minus the left hand side of the equation. Now that I've transposed from the table, which is on the previous question, which was plus 0.77 volts. And if we were to then rearrange that to generate x, we would end up taking across the plus 0.77 volts to the other side, and you'd end up, as a result of rearranging that equation, with 1.25 volts positive voltage. The equation then for the spontaneous cell reaction goes from left to right in that forward direction. So we know we have iron 2 plus going to iron 3 plus, with thallium 3 plus going to thallium 1. So iron 2 plus is going to react with thallium 3 plus. That is going to produce iron 3 plus plus a thallium 1 plus. Now, what we have to bear in mind is we do need to balance out the charges in these equations. So we end up with 2 ions and 2 iron 3. So 2 iron 2 pluses and 2 iron 3 pluses to balance out the charges. 7 positive charges on both hand side. But that can also be explained because the iron 2 plus to iron 3 plus involves the movement of 1 electron. The thallium 1 involved the movement of 2 electrons. So in order to balance out those equations, I need to have 2 lots of iron to mop up and donate the 2 electrons for the thallium.